This video is about solving polynomial inequalities. Now, polynomial inequalities include polynomials of degree 2 or more. For example, 2x2 plus x minus 1 greater than x3 minus x plus 2. This is a polynomial inequality because it has at one polynomial, this one here, of degree 3. So if it's degree 2 or more, we call it polynomial inequality. Now, the idea in solving polynomial inequalities is to use the sign rules. Let's review them here. If you multiply negative number by negative number, that's going to give you positive number. Now here we say number, but it can be an algebraic expression. If you multiply a positive number or expression, that will give you a negative. Positive by positive gives you positive, and negative by positive gives you a negative. Now, suppose you have got more than two numbers or expressions. So, for example, I am multiplying three expressions or numbers. The first one is negative, the second one is positive. So when I multiply them, they are going to give me a negative number or expression. Now I multiply this by the third one. So negative by negative, the whole will give me positive number or expression. That's the idea we are going to use to solve polynomial inequalities. Let's look at example number 1, where we have x2 plus 3x greater than or equal to 4. So step number 1 is to write the inequality in standard form, meaning that one of the sides should be equal to 0. So inequality in standard form. Now this can be written as x2 plus 3x minus 4 on this side and 4 minus 4 on this side. We are subtracting the 4, so that gives me my 0. x2 plus 3x minus 4 greater than or equal to 0. So we are going to analyze that this expression on the left is greater than or equal to 0. Now, to do this, we need to factor, because as it is, it's not easy to analyze the sign. This is like analyzing the sign. So we factor this expression, and that will give me x minus 1 times x plus 4. Now let's check very quickly. X by x give me my x2, and then I have got 4x, x by 4, 4x, and then minus x, that gives me my 3x, and then the minus 4. Good. Now this is so the first step is standard form. The second step is factoring. So second step is factoring. You have to factor the term on the left side. Now once you have factored, things becomes easier, because what we are going to do is to analyze the sign of x minus 1, which we call b, and a, and this one we call b. So a multiplied by b. If you know the sign of a and b, you can find the sign of the product and therefore solve the inequality, because what you are doing now, they're just looking for the sign greater than or equal to 0. Good. Now there is a small thing here to consider, is that a is equal to x minus 1. So the sign of x minus 1 is going to change. It depends on x. So the sign will change. Also x plus 4. So what do we need to do now is to create a table of sign. Now before we create the table, let's analyze the sign of x minus 1 and x plus 4, the two factors. So x minus 1 bigger than 0 means that x bigger than 1. So when x is bigger than 1, this is bigger than 0, and this is bigger than 0 here. Now let's do the second one. X plus 4 bigger than 0. That means x bigger than minus 4. So when x is bigger than minus 4, this term, which is we called b above, will be positive, and if x is less than minus 4, it will be negative. Now we need to make a table. So let's consider this table here. We are going to put the 1 and the minus 4, which are the zeros of x minus 1 and x plus 4 respectively, on the table. Now we put the minus 4, which is the smallest, here, and 1 will go here, and the values here will be, of course, plus infinity, and here it will be minus infinity. Next, we will put the factors x minus 1 and x plus 4 here. Now we know that x minus 1, this one here, it's positive when x is bigger than 1. So when x is bigger than 1, this is positive. If x is less than 1, of course, it will be negative. Good. X plus 4. X plus 4 will be positive when x is bigger than minus 4. Here is minus 4. So this will be positive when x is bigger than minus 4. If it's less, it will be negative. Now remember what we have. We have x minus 1 multiplied by x plus 4, a times b. So here we are going to analyze the left side of the inequality. Now minus by minus on this column, from minus infinity to minus 4, both of them are negative. When we multiply them, they will be positive. From minus 4 to 1, negative by positive, negative by positive. So negative by positive gives me negative, which I put here. The last column, from 1 to plus infinity, we have positive, positive. We put the sign here, the plus here. Good. We are looking for this. Now remember what we are solving. This to be positive or 0. So this interval positive, it's good. This interval, it's positive, good. 0 also taken, so the minus 4 is also a solution, and the 1 is also a solution. Why? Because they give you 0, and our inequality is equal to 0 as well. So let's write the solution. Different ways to write the solution. Let's write it using the inequalities. So x from minus infinity to minus 4, and then we close, and then this one here from 1 to plus infinity, and then we put union. Any value in these two intervals is going to be a solution. Now I think it would have been better to put the number line first, but it's okay, no problem. So the number line will look like this: minus 4, 1. Now equal to 0 is accepted because minus 4 and 1 put at least one of the factors equal to 0. So this is minus infinity to 4, and this is 1 to plus infinity. We can also write the solution using the inequalities. So this interval is written like this, and this interval is written like this. So interval form, graphical form using a number line, and using symbol of inequality. We need to put an or here between the two inequalities. Let's now look at example number 2. So again, the first step, standard form. One side equal to 0. So the above can be written as x minus 2 times x2 minus x minus 2x minus 2 less than 0. Step number 2, factoring. We factor. Now we can see that x minus 2 can be a factor. x2 minus x minus 2 less than 0. Now we need to factor this term here. So that gives me x2. Now x here and x here less than 0. Now I need the minus 2, so it's minus 2 plus 1, because I've got minus 1 here. Let's check it. X by x gives me my x2. And then I have got minus 2x plus x gives me minus x. Minus 2 by 1, minus 2, correct. So now we notice this is x minus 2, x minus 2. So it's x minus 2 power 2, and then x plus 1 less than 0. So we are going to analyze the sign of this term and the sign of this term using a table. Now x minus 2, it's positive or 0. So because it's a square, yeah? Except when x equal to 2, it will be 0. Okay, so this is quite easy here. Now the second factor, x plus 1, will be positive when x is greater than minus 1. Solving, yeah? Solving a linear inequality. And then, so now we put our results into a table. So minus infinity, plus infinity, and then we put the zeros, yeah? This is equal to 0 when x equal to 2. And this is equal to 0 when x equal to minus 1. We can use just the minus 1 here. Now the smallest of these two is the minus 1, so we put minus 1 somewhere here, and we put the 2 somewhere here. And then we start. We have, now remember the two terms. The first one is x minus 1 to the power 2. So we put it here, x minus 1 minus 2 power 2. This is a square. It's always positive, except when x equal to 2, it will be 0. The second factor, so if we look at our inequality, the second factor is x plus 1. And we know that x plus 1 is positive. It's positive when x is bigger than minus 1. This is minus 1. So bigger, it's here. Here, this will be positive. So we go and we put plus here, and negative here. And when x equal to minus 1 exactly, this will be 0. Good. Now remember, we are looking for the sign of x minus 2 multiplied by x plus 1. This is our inequality here. And you are looking for when it is negative. Good. Plus multiply by minus. So negative by positive. This will be negative. Positive multiply positive. We are multiplying. That will give me positive here and positive here. Plus with the plus. We are looking for negative. The product negative. This is the interval when it's negative. This one out, this one out. Let's write the solution. Let's use number line this time first. So this is negative. The product is negative from minus infinity to negative 1. Open circle, because minus 1 is not solution, because there is no equal here. It's strictly less than. Now we're using the interval. It will be minus infinity to minus 1, and then using inequality x less than minus 1. So number line, interval, and inequality symbol. Now let's look at example number 3, which is already factored and in standard form. So all what we need to do is to study the sign of the three factors here. X minus 1 square, x plus 2, x plus 3. Now x minus 1 square, it's always positive or 0. It will be 0 when x equal to 1. Now x plus 2, the second term, x plus 2 will be positive when x is bigger than minus 2. I just solved the linear inequality. The third term, which is x plus 3, it's bigger than 0 when x bigger than minus 3. So now let's put all the information we have together into a table. We start by x minus 1 power 2, the first factor. Now we first put the zeros, yeah? Negative 3, negative 2, and negative 1 from the smallest on the left to the largest. Negative 3, negative 2, and then 1 here. Now we go back to our factor. So x minus 1 power 2 is always positive everywhere, except when x equal to 1 is 0. So we put a 0 here when x equal to 1. Good. X plus 2, the second factor. Now the second factor, x plus 2, it's positive when x is bigger than minus 2. So this is minus 2, bigger than minus 2 in this direction here. And that's where our factor x plus 2 is positive, negative here, negative, and then 0 when x equal minus 2. The last factor, x plus 3. Now x plus 3, it's positive when x is bigger than minus 3. Here is minus 3, bigger is in this direction. That's when it is positive, so we put plus, negative here, and the 0 here. Now remember, at the end of the day, what we need is the sign of all the product. This product here. Let's call it y, because it's quite big. We don't want to rewrite all this. But let's put y here. And then we say positive. So positive multiply negative, it's going to give me plus. And then positive by positive gives me negative. And then positive, here as well positive. Remember, we are looking for when it is either negative or 0. Negative is here. So these intervals are out. So minus 3, minus 2. Do we include the minus 3 and the minus 2 or not? Yes, we include them because they give us 0, and then we want the 0. Equal to 0 is included. So here is the interval, closed here, meaning minus 3 and minus 2 are included. Question, is it the only solutions? Are these the only solutions? No, we have got to be careful because look, when x equal to 1, this factor is 0. If this factor is 0, everything is equal to 0, and then you have equal to 0 accepted. So we say union, the value of 1, x equal to 1 must be included. Number line is very simple. It will follow. In fact, minus 3 closed circle, minus 2 closed circle, all the solutions in between as well. And then somewhere here, just a circle, a closed circle with the value 1. Now, in inequality form, this can be written like this. Now, note the equal here, or x equal to 1, the 1 here, which is also here. Now, for this last example, I would like to go a little bit further and complete the picture of polynomial inequalities. What we have here is the graph of x minus 1 square, x plus 2, and x plus 3, which is what the left term of our inequality. This is plotted here. And we can see graphically that between minus 2 and minus 3 and minus 2, the y, this quantity, which is the y, which is here, this is negative, and this is our interval, the solution. We can also see that when x equal to 1, y is equal to 0, and remember we are solving y less than or equal to 0, so equal to 0 as well. So that completes the solution. In fact, we can solve inequalities graphically, doing just by graphing, as we did here.